So welcome again. So what I'm going to do, I'm going to create I'm going to create one class, and I'm going to write two methods. One to build a linked list, like the earlier program also I have copied that method. If you remember, insert at end, I'll copy that. Then I'm going to write a delete method, and then we'll write the main class and we'll try to run that. Okay. So let me create one class. Delete at position, also a delete node linked list. Okay, fine. Okay, so now in this, let me, as usual, I'm going to create one head first. Now I'm going to write a insert method, so that when I run the method, run the main method, I'm going to create first list, then I'm going to delete, right? So for that purpose, so let me copy that actually. So this is the method that I have to copy. So it's the same code, right? So insert is now done. Now I'm going to write my delete method. Okay, so public void delete at given position. Delete at position. Okay, and in this I'm going to take input position, right? All right. So now first you have to check one use case. What if your list is empty and someone is saying to delete this? Okay, so let's check that first. If head equals to null, it means head is not pointed to any node. It means nothing in the linked list. So system dot out dot print ln, and simply write one message, list is empty, right? And return this. So that edge case is resolved now. What if someone is saying delete the, if position value is 1? So what does it mean? We are going to delete the node which is at the position 1. Or if I say delete the node which is at the start, both are same, right? So I'm going to write a logic for the first node deletion, right? Delete first node or position equal to 1. Both cases are same. Okay. So check if position equal to 1, then simply I have to move my head. If you remember, head equal to head dot next. That's it. Simply return this. Perfect. I hope there is nothing, no doubt in this. I mean, it's very easy and simple. We already discussed on the whiteboard, right? After that, I'm going to do some processing. So if you remember, I told I'm going to create one current node that is pointing to the head itself, right? So a reason I told you, like, why we should write this line. We never do any operation on the head directly. Okay. So first step, we have to traverse the node, just the previous node of that node to be deleted, right? So for int I equal to 1, I'll start, and what should be the I now? I am starting from 1, so I should be less than the position minus 1, right? I should be less than position minus 1, so that I can stay at the previous one, right? And one more condition in this, position should be less than, and I should be less than position minus 1, and your current should not be null. Just to check for the validation purpose, current is not equal to null. It shouldn't be the case when you are trying to go beyond the loop where current is not existing. Okay, current is not equal to null. All right, and I plus plus. We'll keep on doing this. Now in this, I will to simply move my current equal to current dot next. Okay, fine. So this will go there. Now, after execution of this block, I am at the previous node, right? Previous of the targeted node. Let now what I have to do, I have to check whether the position that is asked to delete is a valid position or not. Okay, so if current equals to null, or my current dot next equal to null, in both cases, if it is coming, then the system is asking to delete from an invalid position. So system dot out dot println and then I'm going to return this. Perfect. Okay. If this is not the case, I'm checking the invalid position, right? Let me write here. So if it is a valid position, then what? Then simply I have to move my next to the current dot next, if you remember. Okay. So current dot next should point to the current next to the next, right? Current dot next. This is till now current is pointing to the current dot next, right? But I am just bypassing this. I'm skipping this middle next and I'm going to the next. So in this way, I have bypassed the node to be deleted, right? Then I'm going to print this. So let me copy display method also. If you see here, it's there. Okay. And I have to write now my main method. In main method, I'm going to first delete node linked list that is equal to new delete linked list. Okay. And I'm going to add list dot insert at end. Let me give some number 10 and let me copy this 5 times and make it 20, 30, 40, 50. And now I'm going to delete which one? At any like position 3. So let me print this also. List dot display is there. So this is data before the deletion. Let me copy this one system dot out dot println. I'm going to copy and I'm going to write here before deletion, right? And after that, I'm going to call list dot delete at position number 3. Fine. So output that I'm expecting, this should be removed. So this should be 10, 20, 40, 50. Let me do now list dot display. And this is after. So just for the clarity, let me write here after deletion. All right. So let's see that then. All right. Before deletion 10, 20, 30, 40, 50. And after deletion 10, 20, 40 and 50. And this is what we are expecting, right? So we have seen all the cases, all the edge cases as well. So that's all. What I'll do now, I'll try to solve some famous pattern question based on the linked list. Like one of the very important that might have seen somewhere. Like someone is saying to delete a node, only node reference is given to you. Head is not given. You don't know like from where to start. It's a very, very famous problem and a very, important and tricky problem. So we can solve this. So let's see you in the next one.